Good afternoon to all. We are last class we are discuss linear algebra, differential equations, vector calculus, and some topics. Again, 1 second, I will be recall the same one. Just I will be give the some short introduction to linear algebra. The screen is visible, Amrit?
Yes, sir, visible, sir.
Okay, right. Listen, actually, in this type of questions only we are asking from any gate examinations or we are writing any government sectors. We are asking for the descriptive test questions only. Once we have to take linear algebra topics, they have three possible questions. One is for the rank of the matrix. By using the rank of matrix only, we have to identify consistency of the given linear equations. And from the eigenvalues and eigenvectors, we are asking someone. In our topics, linear algebra, rank of once we asking the rank of matrix, the given matrices we converting to lower triangular or upper triangular matrix. This is the first step. After conversion of lower triangular and upper triangular matrix, we identify the rank of matrix. This is the shortest way of finding rank of matrix. In a rank of matrix, they have to find out the different types of method. But this is only for what? Shortest method. Always we have to follow in this method. This is for the reducible to upper triangular matrix or lower triangular matrix. Here, rank of matrix after conversion of this lower triangular or upper triangular matrix, we identify the rank of matrix. The rank of matrix means the number of non-zero row is called the rank of matrix. So for example, in any one row, all the elements are zero, we consider zero rows. Any one of the element is not equal to zero, we consider non-zero rows. That's all. Okay. If suppose, for example, we see here, this is for the given matrices. In this matrices, we converting upper triangular matrix. Upper triangular matrix means below the diagonal elements we converting to zero. Always using this row reductions. Row reductions relations means suppose we have to converting the first column zero. First column zero. So for example, what are the first column here? 1, 1, 2 is the first column. No. If below the first row, that means 1 and 2. These both are converting to 0 means first column we converting 0. Always use this first row. First row. Okay. So suppose we converting the second row first column we converting to 0. What is the element here? 1. No. We comparing the first row. First row is also the element is what? 1. So just the both elements are what? Same element. No. Just we subtract using the subtraction automatically converting to 0. So we see here the relations R2 is tends to R2 minus R1. So R2 minus R1. Simply using these relations, we get the second row elements. Similarly, third row, first column, we converting to 0. Third row, first column, what is the element here? 2. In this first row, first column, you use using only for the first row. So here, first row, first column element is 1. So first of all, we converting the both elements are same. So we will multiply in row 1 by 2. Multiply 2 in row 1. So automatically 2, 2. Now we subtract. So using these relations R3 minus 2 into R1 for third row relations. In this way only we converting for upper triangular or lower triangular matrix. After conversion of upper triangular, lower triangular matrix, we identify the rank of matrix. In this final step, we see here final step. The third row, all the elements are 0. So we consider it is a 0 rows. But second row, only one element is 0, all others are non-zero values. So it is considered non-zero rows. And first row is also non-zero rows. The totally 2 rows are non-zero rows. So the rank of the matrix is what? 2. In this way is we identify the rank of the matrix. This is for the simple way to find out the rank of the matrix. This is already we seen that last classes. Next, we have to identify linear, the given vector is linear independent or linear dependent. Next one. Okay. So in this case, we use the similar procedure of finding the rank. For example, suppose if we given n vector, suppose if we given 3 vectors, n be this consider 3. Suppose we given the 4 vectors, n is consider 4. If a given vector is n vector, first of all we formed to vector matrices form. After conversion of this, we find out the rank. The rank is also equal to n. N means number of vectors. Suppose if you given the 3 vectors, we will be formed to 3 by 3 matrices. The rank is also 3. It is called a linear independent. Otherwise, it is called a linear dependent. Simply we see here. Here how many vectors is given? X1, x2, x3. 3 vector is given. It's correct. First we formed to matrices A. After formed the matrices, just we have to convert it to upper triangular matrices. After conversion of upper triangular matrix, we identify the linear number of rank. What is the rank here? The number of non-zero row is only 2, no? But the given eigenvector is, vector function is what? 3. But rank is 2. So it is less than 3. So in this case, it is called a linear dependent. Suppose in this examples, we getting the rank is also 3. It is called what? Linear independent. That's all. If you have any doubt for the linear dependent and independent, Maris?
No, sir. Yeah.
Okay. Next. Another one. The third one is consistency of the system of linear equation. Actually, these are only asking objective types, you know. So only within 2 minutes or 3 minutes, within 2 minutes we have to solve the every problem. Okay, it's not asking for the big questions. So just we given simple type of matrices. For example, 3 by 4 matrices is only given. Just we identify what the given matrices is, what is the rank? Otherwise, it is a linear independent or linear dependent. This is for our question. They have given the 3 possibilities: linear dependent, linear independent, and it is none of this above. Otherwise, it is a consistent. Some solution is only will be mentioned. Okay. So the 4 option is given. Just we have to identify within 2 minutes. We have to use this for the shortest way of finding rank and linear dependent and independent. Consistence of system of linear equation. Here very important, if you given any system of linear equations means the power of unknown should be 1. So for example, x power 1, y power 1, z power 1, something is given, it is what? Linear. So system of linear equations means, suppose we given the 3 unknowns, we given 3 equations. Suppose x and y is involving, 2 equation is given. If suppose x, y, z is given, 3 equations parallelly given 3 equations. In this type of equation is called what? System of linear equation. In this system of linear equation is also represented in a matrices form is Ax equal to b. A means the coefficient of unknowns x, y, z. That coefficient is considered capital A. Here instead of x, y, z, x1, x2, x3. And b is for the right hand answers. Okay. First, we form the matrices A comma B. Always we consider what? A comma B. A is uh, this left side of the matrix. B is what? D1, D2, D3. These both are we have to combine first. After we reduce it to upper triangular matrix. After conversion of upper triangular matrix, we identify the rank first. Rank of A and rank of AB. Rank of A means only we consider first 3 columns. Rank of AB means we consider all the columns, the given matrices fully. After, once if rank of A and rank of AB is equal, rank of A and rank of AB both are same, it is should be consistent. Conditioned by the consistency. Next, once it is consistent, there are 2 possible ways we find out the solutions. One is if the rank of A and rank of AB and also equal to n. Here n is called unknowns. Unknowns means the given variables x, y, z is given three different variables. No? So we consider n is equal to 3. Number of unknown is called, we consider n. So the rank of A, rank of AB, and also equal to n. It is inconsistent and unique solution. Only one solution is we got it. Okay. Suppose if rank of A is equal to rank of A comma B less than n. For example, number of unknowns is 3. Suppose the rank of A and rank of AB should be 2 only. That means less than n only we will get it. So it is should be consistent but infinite number of solutions. If the rank of A not equal to rank of B means it is inconsistent. In this case, they have no solutions. This is for what? Consistency and inconsistency. We have to identify for consistency. We check whether consistency of the given linear system of equation. This is for the short concept. Next, so for example, in this problem, it's not given for a equation directly. In our given equations, we given some unknown values. Sometimes it will be given that equation is directly. Just we have to asking the question is, in this given system of linear equation is consistent or inconsistent. That's only we questions. But here they have three possible solutions is given. Three possible solution. In a system of linear equations involving two unknowns, lambda and mu. Just we identify the value of lambda and mu. First, we consider the given system of equation is formed by matrices form A comma B. A means the coefficient of x, y, z, and B is for what? RHS. Or B is right side. After we convert uh, upper triangular matrices. Upper triangular matrix. Upper triangular matrices. After conversion of upper triangular matrices, they have it will be given uh, uh, three possible answers. One is a no solutions, another is unique solutions, and the infinite number of solutions. The three possible solutions is given. No solutions means what is the conditions? Just we see here. If it is inconsistent only, they have no solutions. That means what? Rank of A not equal to rank of AB. Now, we see here the last step of the given matrices. Suppose if lambda minus 3 and mu minus 10, both are we consider 0. Both are we consider 0. So the number of non-zero is what? A is also 2 and A comma B is also 2. So the rank of A and rank of B is equal to, both are similar to equal. So in this case, it is called what? Inconsistent. But no solutions means our condition is what? Inconsistent only, they are getting the no solution. So the no solutions means the rank of A not equal to rank of A comma B. Now in this case, I have to consider lambda minus 3 equal to not equal to 0. Not equal to 0 means what is the rank of A? Only 3 non-zero rows, no? So the rank of A is equal to 3. Suppose mu minus 10 is equal to 0 or not equal to 0. If anything, already I will be take lambda minus 3 is not equal to 0. So the rank of A comma B is also 3. So in this case, only the possibility is, what are the conditions? Lambda minus 3 equal to 0 and mu minus 10 is not equal to 0. Simply will be got it the answers. Okay. Now, similarly, unique solutions means what? The rank of A and rank of AB is also equal to n. Here the n means number of unknowns. What are the number of unknowns? N, X, Y, Z. Three variables, no? So three variables means three unknowns. So n is we consider 3. So the rank of A comma B equal to n is also equal to 3. So this should be the condition is satisfied, then only it is getting unique solutions. So in this case, the rank of A equal to 3 means once lambda minus 3 equal to 0, the rank of A is equal to 2 only will be got it. But we need rank of A is equal to 3. So we consider lambda minus 3 is not equal to 0 and mu minus 10 is any value. Next, infinite number of solutions. When we getting infinite number of solutions? the rank of A not equal to rank of A equal to rank of A comma B less than n. In this case only infinite number of solutions. So what are the possibilities? Rank of A and rank of AB. If we consider, let us assume that lambda minus 3 equal to 0 and mu minus 10 is equal to 0, then only we getting the rank of A and rank of A comma B is also equal to 2. But number of unknowns is 3. So less than n, no. So in this case, it is satisfied infinite number of solution. This is for the discussion about the consistency of linear system of linear equations. Next one, eigenvalues and eigenvectors. Actually, eigenvectors means suppose you want these eigenvalues and eigenvectors, we have to follow these procedures. That means these are the steps. Let A be the given square matrix, the characteristic equation next we find out. After getting this characteristic equation, we solve the characteristic equation, we get the lambda 1, lambda 2, lambda 3. This lambda is called eigenvalues. After finding the lambda eigenvalues, we find out eigenvectors. In eigenvectors, first we form the system of linear equation. A minus lambda I into x is equal to 0. Here A be this given matrix, lambda is eigenvalue, I is identity matrix, and x is called, here unknown, no, x is called eigenvectors. That's all. Actually, this is for the procedure to find eigenvalues and eigenvectors. But in our cases, it is already we studied in our first semester. But in our competitive examinations, only we have to asking for the short answer. Short answers means by using the properties only with the questions. In eigenvalues, eigenvectors concept, in everyone, they have using only for two different properties. Most of them we are using these first two properties only. The first two properties means the sum of the eigenvalues of A is equal to the sum of the principal diagonal elements of A. Similarly, the product of eigenvalues means is also equal to determinant of A. These two properties only they have using what 99% we are using these objective types of questions. Next, once we know this eigenvalues of A, once we know this eigenvalues of A, for example, lambda be this eigenvalues of A means inverse of eigenvalues of A inverse means just we take inverse. A square means just we take the square. Suppose you want this 2A means scalar multiplication means just we multiply by 2. Next, if once we given the diagonal elements, sorry, upper triangular, given matrices is upper triangular or lower triangular, directly we have to identify the eigenvalues. The diagonal elements is called what? Eigenvalues and the eigenvalues. Suppose below the diagonal elements or above the diagonal elements are all the elements are 0, the eigenvalues are what? The diagonal elements are also called eigenvalues. This is for the simple concepts. Okay. Next, the eigenvalues of A and A transpose are same. That's all. This is for already we seen the last class. Just I will be 1 second. I will be recall the concept. Okay. If you get any doubt for matrices, linear algebra, anyone? We are in line. Anyone? Amrit? Amrit?
So no, sir.
Okay, thank you. Next. Now, I will be send it notes, all the notes in your anyone mail ID. Okay, just we have to share everyone. The last class, some of the students will be interact to me, but I not hear me. If you have any interaction, please just unmute your audios. We ask the questions. And now, just I will be recall the differential equations. Not necessary. Ah, well, listen. Once we given the differential equations, first we know this identify the order and the degree. Order means highest derivative is called order. Derivatives means dy by dx means first order. D square y by dx square means 2 times derivative, no? So it is called a second order. Suppose e cube y by dx cube means third order. That's all. Degree means degree. Degree means we see that order, highest order. That means third order derivative. For example, equation 2, d cube y by dx cube. No, this is for third order derivatives. This power, what is the power here? Whole to the power 2. From the, we suppose we consider equation 1, higher order is here, second order, d square y by dx square. This corresponding power is what? 1, no? So in this case, it is called order is 2, degree is 1. That is a meaning. Yeah, class எனக்கு இப்போ நான் ரெக்கார்டட் கிளாஸ் ஒரு நிமிஷம் இல்லை இல்லை next we using the notations for the differential equation capital D square. Capital D, always use the notation capital D. Capital D means a differentiation with respect to x. D square means d square by dx square. We know this capital D means a differentiation, no? So the corresponding inverse 1 by d means integration. 1 by d square means integration with respect to x in twice. That's all, and so on. Similarly, we have to identify. Once we given the differential equations, in our question is only we are asking the complementary functions or particular integral. In this way only the asking the questions, only complementary functions or only particular integral. In first we are asking the differential equations. First of all, always we find out auxiliary equations. Auxiliary equations means just we replace d by m given the differential equations of the characteristic equation and the right side always we consider what? 0. In d replaced by m here, so a not m square plus a1 m plus a2 equal to 0. In this form we got it. So here we taking only second order equation. Suppose we taking the third order equations, they have getting cubic equation. uh, Once we given the quadratic equation, we use the formula minus b plus or minus root of b square minus 4ac. Suppose we given more than 2 order, you know this one of the synthetic division, no? L by using this L method, synthetic division. Using synthetic division, we have to solve the equations. We get the value of m. This m is called the roots of the equation. After getting the roots, depending on the roots, the complementary functions, they have 3 cases. One is if the roots real and equal, the complementary function is a plus bx into e power mx. Suppose if the roots are m1 real and different, complementary function is a into e power m1x plus b into e power m2x. If the roots are real and imaginary, e power alpha x, a cos beta x plus b sin beta x. In this way only we have to identify the complementary function. Sometimes the given question is only solved. Once we are asking the question is solved, the right side of the function is given 0. The complementary functions only solutions. Okay. Now the particular integral. In a particular integral, they have different ways, but we have to concentrate only for 4 different ways. Suppose you using this any textbook or any local author book, they have different types of solutions of particular integral is given, but in a particular integral they have maximum we are asking this 4 type is very important. Once we identify the function, then easily to study the functions also. If e power something is that, this function is called exponential. Once we give an exponential function, the substitution of differential equation is capital D is equal to a. Next, trigonometry functions. Trigonometry means if sin ax or cos ax, if anything is given, the substitution is d square equal to minus of a square. Suppose the function involving capital D only, we know this only d square equal to minus of a square, no? So once we given d only, we use by using the conjugate, we convert it to d square. So for example, we see here the second step, 1 by d plus a only is there. So we in a trigonometry functions, we know this substitution d square equal to minus of a square, but here only d plus a is there. In this case, In this middle of the sign, we have to interchange. The plus is given minus, minus is given plus. After we will be multiply and divided. Just denominator what we will be getting, a plus b into a minus b, a square minus b square formula. No? So automatically denominator what will be formed, d square we got. After conversion of d square, again we substitute minus of a square. We get the solutions. Next, algebraic. X raised to something is their algebraic function. In this case, denominator we converting to 1 plus x or 1 minus x form. After we converting numerator we convert. So automatically what will be get 1 plus x whole inverse, 1 minus x whole inverse form is wedged. In this case, after this, in this formula is called binomial expansions. Actually, by using the binomial expansions, here also very simple. The both the sign plus minus is the alternative sign. Both the sign are same. Minus minus is a similar sign. No, so all are positive. That's all. In this way, we expand the formula. After we will be multiply the given algebraic function. Suppose if it will be involving d, we use the first derivative. If it will be involving d square, we use the second derivative, and we have to proceed for these steps. Next, already we are seeing three different types: exponential, trigonometry, and algebraic. Now if exponential multiply with any others, if we exponential multiply with any others, instead of exponential we replace d by d plus a. If we multiplying algebraic, use the third type. If multiplying trigonometry, use the second type. That's all. It is called the differential solutions of differential equations with constant coefficients. Next, Euler's-Cauchy's equations. In this is there are two possibilities. One is, our question is, convert the given Euler's-Cauchy's equations into differential equations with the constant coefficients. Actually, it is called differential equations with the variable coefficient, because all the derivative coefficients involving what, x square, x, and so on. So it is called what, differential equations with the variable coefficients. Suppose you, this is very simple. In the, if a given Cauchy's equations, we have to follow this ordinary method only. But before that, we converted to differential equations with the constant coefficients. Suppose we need to differential equations with the constant coefficient. These are for substitutions. That means x equal to e power z, z equal to log x. Actually, x is substitution is x equal to e power z only. Both the side we taking logarithm, so log x equal to log e power z. Simply logarithm exponential cancel, so we getting z. That's all. Next, both the side we differentiate, automatically x dy by dx equal to what will be get, theta y. Here theta means d by dz. Differentiation with respect to z. The second order, d x square d square y by dx square means theta into theta minus 1 into y. We substituting these all the thing in this above equation, automatically what will be converted, the differential equations with constant coefficients. Next, in this first type, we using the notation x d by dx only. But here instead of x z, instead of theta d theta, d by dx is d by dz. That's all. Okay. Next, now this applications of differential equations is for boundary value problem. Actually, these mechanical students are we have to we have to study for this boundary value problem only. Here, once the classifications, how to identify the given partial differential equation is elliptic or parabolic or hyperbolic. This is a very important questions. First, we identify ABC. ABC be this coefficient of dou square u by dou x square, dou square u by dou x dou y, dou square u by dou y square. Only we consider these three terms only. If given any partial differential equations, only we consider the second order. The second order coefficients we consider capital A, capital B, capital C. After we calculate the value of b square minus 4ac. B square minus 4ac. They have three possibilities only: negative, that means less than 0, or equal to 0, or greater than 0, positive values. One is negative value or equal to 0 or positive values. In this case, If once the b square minus 4 is less than 0, it is elliptic. Equal to 0, it is called what? Parabolic. If greater than 0, it is called hyperbolic. Okay. In this three equation is one, the three different types of equations: elliptic, parabolic, hyperbolic. Only we define by wave equation. This is called a wave equation. By using separable variable method, we have to identify these are the solutions, three possible solutions. And another one is heat equation. This is called a heat equation. Dou u by dou t equal to alpha square dou square u by dou x square. Here also, by using the separable variable method, we solving this equation. These are the possible solutions. And the last one is two-dimensional heat equation. That means we consider a Laplace equation. Dou square u by dou x square plus dou square u by dou y square equal to 0. In this equation is called what? Laplace equation. We using this separable variable method, we get three possible solutions. That's all. This is for the topic of differential equations. If you have any doubt, any clarifications for this? No? Right. Next one is vector calculus. Here, in a vector calculus, here we are using the three-dimensional. If we will be involving only for magnitudes, no directions, so it is scalar point function. For example, pi is x square plus y square plus z square. It is called what? Scalar function. In a vector function means, suppose if f vector equal to x square I plus y square j plus z square k. If you will be involving the vector, magnitude with directions, it is called what? Vector function. In this vector calculus, by using this scalar function and vector functions, we have to operate differential operations. We using differential operations. Differential means del. It is called a del. Dou by dou xi plus dou by dou ij plus dou by dou z k. This notation is called del. Now I have to using for this operation with scalar and vector function. Once we using the scalar function, this notation will be multiplied with the differential operator with scalar function. That means a del phi. It is called a gradient vectors. Suppose by using the gradient vectors, I have find out that some different values: unit normal vectors, directional derivatives, angle between two surfaces, and orthogonal surfaces. These are we have to derive from scalar vectors. That means gradient vectors. By using gradient vectors, they have find out these concepts. Next, divergent vector. Divergent vectors means from the given vector point functions, we take in dot product. It is called what? Divergent vectors. So the divergence f vector equal to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. This is for the definitions of divergent vectors. If a curl vector means this vector in vector function, we take in the cross product. It is called what? Curl vector. Cross product means we take the determinant. We know this, the directions is what? Ijk. In differential operators involving the notation is what? Coefficient of ijk, dou by dou x, dou by dou y, dou by dou z. In vector function coefficient is f1, f2, f3. We form the matrices form. After we take determinant, simply will be got it curl vectors. By using the curl and the divergence vectors, we have to use it for some integral theorems, and also once if a divergence vector equal to 0, it is called a solenoidal. This is very important. If once curl vector equal to 0, it is called what? Irrotational. Next, these are the properties of divergence and curl. Suppose in our questions any vector functions, just to find out divergence of curl vector means don't derivate. Okay, don't simplify the vector formulas. Directly we have to write what? 0. If we given a vector, any vector functions, divergence of curl F vector equal to what? 0. Similarly, if will be given any scalar functions, suppose we have to find out curl of gradient phi means that is also what? Automatically 0. So don't need to find all the derivatives. Directly we have to identify the corresponding values. Because suppose if for example, I will be given some problem, phi is given x square plus y square plus z square. What is the value of curl of gradient phi? It will be mentioned by 0, 1, minus 1 and infinite. Something is given. Directly don't need to find out the values. Directly we written 0. In this way we have to use it for in these types of identifications. Okay. Next, line integral means we are to using only for one dimension. Suppose you want this length of any curve, length of curve, we have to use the line integral. You want this, what is the distance of the any straight line, you have to use this line integral. Surface means suppose you are asking the area, suppose you are asking the area, we use the surface integral, double integral over s f vector dot ds square. This is the formula for surface integral. You want this volume. What is the volume of cube? Suppose you ask the question is volume of the cube is asking, triple integral over v into dv. This is for the volume integral. These depending on these three integral, that means the surface, line and volume integral, we have to identify three different types of theorem. Uh, Here the only possible way is we are asking statement of the theorem, Green's theorem. Green's theorem we comparing line and the surface, but here only for xy directions only we given, because the formula is involving b dx plus b into dy. No, so the plane is here should be will be mentioned. So only the region is given xy plane only. So it is for the Green's theorem. But Stokes theorem we given we comparing the line and the surface, but it's not mentioned by the plane, xy plane, y is that plane, z is that plane. These are it's not mentioned. Here one more theorem is there, Gauss divergence theorem.
பத்திரமா பேப்பர் முடிச்சு
Okay, now Gauss divergence theorem means this is the divergence theorem. We have to compare with the surface and the volume integral. Okay, this is for what? Gauss divergence theorem. These are the possible recalling vector calculus. Okay, any doubt for the vector calculus? Anyone? Anyone? No. We are in line. Are you audible for this? Audible? Amrit?
Sir, audible, sir.
Okay, thank you. Right, next one, complex variable. Actually, this is a how many topic is there? I will be refer small important concepts only. Complex functions. This complex function, it is called a complex function. All are we know this. Complex numbers means what? Once we will be involving real and imaginary, it is what? Complex numbers. So this complex function is also called what? Analytic function. Once the complex function is satisfy some conditions, some one conditions, it is called what? Analytic functions. So for example, if you given any complex function satisfy Riemann equations, what is CR equation? CR equation is, this is called the CR equation. Dou u by dou x equal to dou v by dou y, and dou u by dou y equal to minus dou v by dou x. This is called what? CR equations in Cartesian form. Cartesian, what is the meaning for Cartesian means? If once the function is involving xy, in terms of xy is there, it is called what? Cartesian. Suppose we will be involving the notation in terms of radius r and theta angle. R and theta is, it is called polar coordinates. If you are given Cartesian form, the CR equation is dou u by dou x equal to dou v by dou y, and dou u by dou y equal to minus dou u by dou x. So it is a CR equation, no? If any given complex function is satisfy the CR equation, it is called what? Analytic functions. Okay. So suppose you have to check whether the given function is analytic. This for our questions means just we verify CR equation. It is satisfied. Simply we have to answer yes, it is analytic function. That's all. Otherwise, it is not a analytic function. So next, already we know that in this last topic we have seen that the Laplace equation, the two-dimensional heat equation. Once dou square u by dou x square plus dou square u by dou y square equal to 0. It is called what? Laplace equation. Once the Laplace equation is satisfied, the given analytic function, the given real or imaginary function is also called harmonic function. Okay, harmonic functions. These are the examples of harmonic functions. Already we discussed in the last class. Just I go through for the next one. Next, complex integration. From the complex integrations only, Cauchy's theorem or Cauchy's fundamental theorem. Suppose the Cauchy any functions f of t is f of z or f of t is analytic, and its derivative is f dash of z is continuous at the point that then by the Cauchy's theorem integral over c f of z is equal to 0. Similarly, in Cauchy's integral formula is f of a equal to 1 by 2 pi I integral over c. Here c is the enclosed the simple connections of the region capital R. Integral over c f of z by z minus a into dz. This is a formula for Cauchy's integral formula. From the Cauchy's integral formula or Cauchy's residues theorem, both are similar to find out any integral. That's all. We're using any integral. But here, once the given integral of the integral, we identify the pole of the given function. The pole is lies or the pole of the pole is lies inside the circle or inside the given region. Then only I find out the value of given integral by using integral formula or residues formula. Otherwise, automatically the given integral equal to 0. Most of the question, your question is only discrete type, no? So most of the questions, our given pole of the equation should be what lies outside the given region. In this way only the question is given. So automatically what will be written? The given integral equal to 0. For example, so it is for the Cauchy's integral formula. Next, Cauchy's residues theorem. Cauchy's residues theorem means integral over c f of z d is 2 pi I into sum of the residues. Okay, this both theorem is similar to find the given integral values. Okay, you have to use any one of the methods. If using this residues theorem, we need to find out residues values also. In a residues, they have only two formula, only one formula, but here the table for more than 4, 5, 6 formulas. But here it's need for only two formulas. In the first one we see here z equal to a is a simple pole, then the residues is equal to limit z tends to a z minus a into f of z. This is one of the formula. Another one, if the pole of order is m, the last one. If you want the pole of order is m, we replace m by order is 2, m equal to 2. Order is 3, m is equal to 3. If order is 1, it is called a simple pole. So once order is 1, m is equal to 1, we replace. Generally, the pole of residues of at any z is equal to a 1 by m minus 1 factorial limit z tends to a d power m minus 1 dz power m minus 1 z minus a whole power m into f of z. This is for the formula for residues. Similarly, This is a formula for Taylor series. Taylor series expansions means if once f of z is analytic inside the C with center A and radius is R, then each point of z inside C. The formula for Taylor series is f of z equal to f of A plus z minus A, f dash of A by 1 factorial, f double dash of A by 2 factorial, z minus A whole square, and so on. Once we taking instead of A is equal to 0, it is also called what? Maclaurin series. That's all. The point is given, just we substitute the point, value is A. Because the point is not mentioned, directly we will be considered the point A is equal to 0. The series is called what? Maclaurin series. Okay. So this is for the complex integration and complex variable. Simply we have to take for this simple problem. Evaluate integral over C dz by z plus a, sorry, z plus 4, where C is the given circle. Always we given C is the closed region. Okay. Here C be the circle. Circle. Circle equation is given what? Mod z is equal to 2. Just we have to draw this given equation. Will be get center of the circle is 0 comma 0 and radius is equal to 2, because here mod z is equal to 2, no? So z means complex variable. Will be complex means what? Real and imaginary variable. So we consider x plus iy be this z. So we modulus of x plus iy, how to return? We take the modulus. Modulus means magnitude. Root of x square plus y square. So squaring on both sides. So x square plus y square equal to 2 square. So we got it the equation what? X square plus y square equal to 2 square. So you know this is the equation of the circle. We identify the center and radius. So center is origin, radius is equal to 2. Simply we draw the graph. After we identify the pole value. Pole means with the given integral we identify the denominator. What is the identification of denominator here? Z plus 4. Just equating to 0, we identify the value of z. So z plus 4 equal to 0. So simply we will get z is equal to minus 4. Z equal to minus 4 means minus 4. Only real value, no? So just we see that x-axis. So minus 4 is the left side of the given graph. It's correct. So minus 4 is lies outside the, here the radius of the circle is 2 only. So minus 4 is lies outside of the circle. So once the pole is lies outside, what is the given integral? Simply will be written 0. So our answer is what? 0. In this way only we have to identify or find all the integral values. Okay. This is for the complex variable. This also I will be discussed the last class. Okay. These all the points are will be discussed for last class. Now we are to seeing for a more topic, integration. Here we are using for two different ways: double integral and triple integral. Double integral means what? Multiple integral, no? Multiple integral we have to find out for the area of the given region. Suppose you want this area of the region, just using this multiple integral, we'll be getting the solutions. Here, it is definite integral. Definite means we given the limits. Sometimes we given indefinite integral. Limit is not given, you only we identify the limits. This is for the multiple integral, no? So we are double integral over 0 to 1, 0 to 2. dx, sorry, xy, dy, dx. Now listen, first we identify the value of given limits. What are the x variables, what are the y variables? This is only we identify first. Now we leave this the first integral and last integrating variable. That means first integral we leave them. Next xy dy. First integrating what? Dy, no? So the second integral value is for the limit of y here. So y varies from 0 to 2. X varies from 0 to 1. If once you given the both the limits are constant, you are convenient. First we integrate with respect to y or integrate with respect to x. Once we integrating with respect to x, y is considered constant. Integrating with respect to y means x is considered constant. Integrating with respect to x means y is we consider constant. Now in this problem, first integrate with respect to y. So x limit and x is we take outside. Y integration y squared by 2. So the corresponding limit of y is what? 0 to 2. After integration, we substitute the limits. 2 square minus 0 divided by 2. So we are getting simply 2. Next x. With respect to x integration is x integration x squared by 2. What is the limit of x? 0 to 1. Just we substitute, we will get 1. In this way only we find out the constant limits. Similarly, if once we given the variable limits, so for example, we see here the limit of values 0 to a. This is a constant because in the multiple integral here we consider the variables are x and y. And the second limit of value is 0 to root of a y. So here y is there. Y means y be the variable. In this case, the identification of limit is once we involving the limit is y, the corresponding limit of value is x, another variable. Now x varies from 0 to root of a y varies from 0 to a, xy, dx, dy. First always integrate with respect to variable limit. Now I will be integrate with respect to x. So x integration x square by 2. Limit of x is we know this 0 to root of ay. So after we substitute 0 to ay, we substitute the limits and then minus of lower limit. Root of ay minus of lower limit. After substitution and simplification, again we integrate with respect to y. Now y limits from 0 to a. Just we substitute. Instead of y is equal to upper limit a, then minus of lower limit 0. Simply will be got a power 4 divided by 6. Another cases. What are the another possibility? In the third examples, we see here the limit of value is 0 to 1 and 0 to root of 1 plus x square. In this limits involving 0 to x square, no? So x is there. So the corresponding limit is opponent variable. So y varies from 0 to root of 1 plus x square and x varies from 0 to 1. Now first always in here in this case first always integrate with respect to y only. So integrate with respect to y, x is we consider constant. So y square plus the remaining terms we considering constant. Already we know this the formula for dx by integral dx by x square plus a square is what? Tan inverse of x by a. Here x be this y, the remaining we consider constant terms. We formed it to a square form. After we apply the formula 1 by a tan inverse of x by a. The value of y is we know this 0 to root of 1 plus x square. We substitute upper and minus of lower limit tan inverse of 1 minus tan inverse of 0. After get tan inverse of 1 we know this 5 by 4. Tan inverse of 0 is 0. After integral 0 to 1, 1 by root of 1 plus x square dx. Again we will be integrate with respect to x. We will get the solutions of the given integral is 5 by 4 into log of root 2 plus 1. This is a multiple integral. Okay. In this way we have to work it out further. We see here this last example 6th. Integral over minus 5 by 2 to plus 5 by 2 and another one 0 to 2 cos theta r square dr d theta. Here given the variable of integral variable is r and theta. This is called the polar form. This is what polar form. The similar for x and y. Here theta is given, no? Limit of values in terms of theta is given. So this corresponding limit of value is opponent variable. So what? R. So R varies from 0 to 2 cos theta. Theta varies from minus pi by 2 to plus pi by 2. First integrate with respect to R. After substitution of R limits, again we integrate with respect to theta, and again we substitute the corresponding value of thetas. We simplify, we get the solutions. This is a procedure to find double integrations. Okay. In this double integration, simply the applications of double integration is what? Just we have to identify the area of any region. So, for example, in our questions, evaluate double integral over x per y dy dx over the positive quadrant. So here of ellipse, we know this the equation of ellipse. What x square by x square plus y square plus by d square is equal to 1. This is for equation of the ellipse. Just we draw the graph. This is a graph of ellipse. In our questions, only the region is considered what positive quadrant of the ellipse. So only we take the first quadrant. From the first quadrant, we have to identify the limits. We take the strip is parallel to x-axis or parallel to y-axis. That means horizontal or vertical strip. Suppose if it is taking vertical strip, y is a variable limit, x is a constant limit. Suppose we taking the horizontal strip, x be this variable, y be the constant limits. Now here I will take the strip is parallel to y-axis. That means vertical strip. So just we see that the lower and upper end of the strip, lower and upper end of the strip. The lower end is touched with x-axis. You know this the equation of x-axis is y equal to 0. Upper end we touch with this ellipse. So equation of ellipse is x square by a square plus y square plus b square is equal to 1. From the equations we find out y. So y is simply we got it b by a root of a square minus y square. After this x the radius of ellipse is what? Only the first quadrants. So 0 to a. The x varies from 0 to a. Now we substitute the limits for the given integral. Again we formed to the first concept. Directly when we integrate, we get the solutions. A cube b square by 15. That's all. Next, triple integral. This is useful to find the volume of the given region. Here, evaluate integral 0 to 1, 0 to 1 minus x, 0 to 1 minus x minus y, dx, x, y, z, d, z, dy, dx. Okay. Here will be mentioned by three different variables x, y, z. First, we identify the limit of given integral. You see here, the first integral only will be involving the constant values 0 and 1. Second one 0 to 1 minus x. X only is there. Next 0, 1 minus x minus y. Here what variable is not, not in the limits z and no. So the z varies from 0 to 1 minus x minus y. So now we got it z limits. Let's see that another one. Another variable is involving in terms of x. So the corresponding limit is y. Next one, last one, the limit of x. X varies from 0 to 1. After, first always we will be integrate with respect to two variable limit. Two variable limit means where z is 0 to 1 minus x minus y. No? So integrate with respect to z is first. So z integration is squared by 2. Here 1 by 2 is taken outside. After integration, you substitute the limits 0 to 1 minus x minus y. Next, we integrate with respect to y. After y, we substitute the limit of y. Next, integrate with respect to x. Finally, we will get the solution is 1 by 720. In this way only we identify triple integral. These are integrations of our syllabus. Simple questions only we are asking our competitive examinations. Just how to integrate, which one is integrating variable. Once we know this identification of the limits, easily to identify the solutions also. Yeah. If you get any doubt, any doubt, any Amrit, any doubt, Amrit,
No, sir. No,
right?
sir. No, sir.
This is for our integrations. And next one, this numerical methods and probability. These two concepts is available in our syllabus. First, I have to see that probability. No, see here. Probability. Already we know that. All we studied in the fourth semester, probability and statistics. It's correct. Um, in a probability, first we identify for the basic definitions. First, random experiment. Random experiment means suppose if using suppose we tossing a coin, it is for one of the random experiment. Suppose you throwing a die, it is also what one of the random experiment. In this random experiments, number of events, that means number of events in our coin, that is for what outcomes, total number of events. For example, so we consider the coin in a coin head and tail, no? It is for outcomes. It is the set of all possible outcome is also called what? Sample space. Set of all possible outcome is also called what? Sample space. For example, two coins are tossing at a time. What are the possibilities? Head, tail, tail, head, tail, tail, head, head. These are all the possible outcome. No? So it is called a what? Sample space. If a even means even is non-empty subset of S. From the sample space, non-empty subset is called what? Even. Favorable even. Favorable even means number of outcome which causes the occurrence of events is called what? Favorable even. Suppose if we are tossing a coin, what is our expectations? I want, suppose I tossing a coin, what is our expectation? I need to head, head be the favorable event. Suppose I ask the tail, tail be the favorable event. Mutually exclusive events. Mutually exclusive events means simply two events A and B are said to be mutually exclusive events. The intersections, this common intersection should be what? Empty. It is called what? Mutually exclusive events. Independent event. Independent events means the happening or non-happening events is not affected by the happening or non-happening of the other events. So, for examples, tossing a coin, the event heading head in the first tosses is independent of getting the head in the second tosses. That's all. This is called our independent event. Very important. The probability of any random experiments. If we have random experiments, in a random experiment, probability of any favorable event. Suppose you consider E be the favorable event. Probability of any favorable event equal to number of favorable divided by number of sample space. Number of favorable divided by number of sample space. So for example, suppose tossing a coin. What is the probability of getting head? This is for our questions. So for example, tossing a coin. What is the probability of getting head means in a coin number of samples is 2. That's correct. Head and tail. So the number of sample is 2. So we take the denominator is 2. Number of favorable. Suppose head means in a coin, how many head is available? Only one head. No? So the 1 by 2. So the probability of any favorable event is equal to number of favorable divided by number of samples. So the number of favorable is 1. Number of sample is 2. So the probability of getting head or tail anything what will be answers? 1 by 2. So it is for the definitions of probability. Next one, it is very important to note it, the result. No, this is for the axiom of probability. Axiom of probabilities means if any probability of favorable event is should lies between 0 and 1. If you're taking any event, any random experiment, probability of favorable is what? Lies between 0 and 1. 0 to 1 is the answers. Next, probability of impossible event. Impossible event means the event is empty, is always what? 0. That is called the probability of pi is equal to 0. Empty events we consider high. Next, the probability of sample space, the total sample, probability of S should be 1, because the probability of total probability should be 1. Next, if addition theorem, if a probability A and B are not mutually exclusive events, probability of A union B will be written as P of A plus P of B minus P of A intersection A union. Sorry, it's not A union. We have to change this A intersection B. The probability of A union B is equal to P of A plus P of B minus probability of A intersection B. This is a additional theorems for the probability. Suppose in this same one, if A and B are mutually exclusive events. Mutual means what? If intersection should be empty. If A and B are mutually exclusive events, probability of A union B will be written as P of A plus probability of B only. That's will be given the next one. Probability of A union B equal to what? P of A plus P of B. It is called when this condition is satisfied if A and B are mutually exclusive events. Okay. If three events are given, suppose we consider three events A, B, C. Probability of A union B union C will be written as P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus A intersection C plus B probability of A intersection B intersection C. We consider this is a formula for additional theorems. For now, already we know this is the permutation combination NCR. No, N be this favorable event. Suppose using the permutation combination NCR, N be this number of events, or if you consider favorable events. Using this concept, simply we will get the answers. For example, we see here a bag contains. Consider a bag. Bag is one of the random experiment. From the random experiment, hello, class இருக்குங்க 2 hours class gate class recordable. Okay, so a bag is contain 4 green, 6 black and 7 white balls. So a bag contains some events, 3 different events, green, black and white balls is correct. So the bag is total number of balls. How many balls? 4 plus 6 plus 7. So totally 7 ball is there. A ball is drawn at random. So now from the bag, one ball is taken at randomly. Our question is, what is the probability that it is either green or black ball? You see here, we are very simple. How many ball will be taken? Only ball, one ball. The ball is taken at random. Only one ball is taken. Here the possibility is either green or black. Either green or black. But now we have to choose from the bag one green ball. That we consider A. That means E1. How many black? How many green ball? Only 4 ball. So how many ball will be taken? One ball. So 4C1 be this number of E1. Similarly, or black ball. So we consider E to be this another one, black ball. So number of E2 is how many black ball? 6 black ball. From the 6 ball, we taken only one ball. It's correct. So 6C1. So a number of E2 is 6C1. 6C1 is also 6. You know this the definitions of probability. Number of favorable divided by number of sample. No, sample means from the sample space. How many sample space here? 4 green, 6 black, and 7 white. So totally 17 balls. From the 17 ball, we taken one. No, so the number of sample space is 17 C1. That is also 17. Now here we drawn only one ball. No, if you have any possibilities getting the both the colors, green and black. No, so only the possibility is green only or black only. It's not both. So the A intersection, that means E1 intersection E2 should be what? Empty. So it is called a mutually exclusive events. So suppose the same. Now you want this required probability. Probability of E1 equal to 1. E1 number of green ball. The number of green ball is 4 green ball divided by total number of ball is 17. So 4 by 17. Number of white black ball is 6 by 17. So the totally 10 by 17 is your required answer. The similar one, suppose we consider the similar problem. A pack of cards. Already we know this. We know that the cards in a pack of cards totally how many cards? 52 cards. 52 cards. Suppose in a pack of cards, a card is drawn at random. A card is drawn at random. One card is will be taken from the pack of cards. What is the probability of that is getting from king or queen? King or queen. In a pack of cards, totally 52. They have 4 varieties. It's correct. Dice, 14, spare, clever. So each variety is 13 card. In a 13 card also, A. A B this you consider 1 and 14 also. S. 2 to 10 number. Next Jack, Queen, King. These are varieties of each varieties. These are parts of each varieties. It's correct. 13 card variety. Suppose the question is asking what is the possibilities of getting green or sorry queen or king in a pack of cards. Queen card is 4. So total number of cards is 52. So the probability of getting green queen card is 4 by 52. This is the answers for probability. Similarly, king card is also 4 by 52. It's correct. They have any possibilities for both? No possibilities. Queen and king, it's not involving for single in a single card. So it is called a mutually exclusive event. Suppose in the same example, a card is drawn from the any pack of cards. What is the probability of getting red or king? Suppose the question is asking red or king. Red means how many red cards? Dice and heartings both are involving the color is red. So 13 plus 13, 26. 26 divided by 52. So the probability of getting red card is 26 by 52. So 1 by 2. King card is only 4 cards. 4 variety 4 cards is there. So 4 by 52. It is for probability of getting king card. If any possibilities for both king and red, you think in this case it's not mutually exclusive events. King and red is 2 cards. Dice and hearting both are red color and king also there. So 2 by 52. So in this case it is not mutually exclusive events. So we have to find out and identify for in this way. These are the examples for the same thing. Next, conditional and independent events. conditional and independent event. Here, if A and B are independent, if A and B are independent event, then the probability of A intersection B will be written as probability of A into probability of B. In a conditional probability, probability of A given B is equal to probability of A intersection B divided by probability of B. If probability of B is not equal to 0, that should be greater than 0. Otherwise, we take probability of B by A is equal to probability of A intersection B divided by P of A. Here, if probability of A is not equal to 0, this is called conditional probability. Now, by using this conditional probability, we have to work out for this. We end up clarifying the next one. We have to define by the theorems total probability and Bayes theorems. The total probability means, see here the last one. Sum of I is equal to 1 to n. Probability of E1 into probability of A by EI. EI, probability of A by A. This is for total probability. Bayes theorem means probability of EI by A. Probability of EI into probability of A by EI divided by sum of I is equal to 1 to n probability of EI, probability of A by A. This is the total probability and Bayes theorems all are we are using. If anywhere, if you're using this more than one random experiment, more than one random experiment, suppose a pack of a box contains some events. You're taking any one ball or any two balls. What is the probability of getting red or white? Something is asking. We use this normal concept. Mutually exclusive events, conditional probability, total probability, and so on. Suppose a bag one contains some events. 3 white ball, 4 black ball, and 5 red ball, something. And one more bag is contains 2 white ball, 3 white ball, 3 black ball, and 2 red ball, something is there. And one more bag. Bag 3 is also contains some balls, some events. Here, in this types of experiment, we have to consider total probability or Bayes theorem. That means more than one random experiments is involving. We are used for total probability or Bayes theorems. In this random experiment, suppose we select only one of the event from any experiment. Any experiment, we select any event. In our question is, once we know this event, once we know this the event, we consider always Bayes theorem. Once the event is unknown, is consider total probability. So for example, a bag contains 2 red and 2 white. Another bag contains 4 red and 4 white. From the bag, and from the bag 1, we taking 2 ball at random. 2 ball at random. I am not taking for any colors. 2 ball at random and place it in the second bag. Again, we choose from the second bag. We choose any one of the event at random. What is the probability of getting red? The question is, I don't know for the event, but our question is only what is the probability of getting red event. So it is using the total probability because the event is unknown. The same thing, We choose any one bag at random. The same experiment. We choose any one of the bag at random. One or two, anyone. From the bag, we taking two balls. One is red and one is white. One is red and one is white. Now we know this the event name. Event is known. What is the probability of getting this event from the bag one? From the bag one. So event is known, the experiment is unknown. So in this case, we use the Bayes theorems. This is for the concept of Bayes and the total probability. So for example, simple examples, you see here. The chances of Dr. A will diagnose diseases X correctly 6%. So diseases is X correctly is 60%. The chances that patient will die by the treatment after correct the diagnosis is 40%. The chances of death wrong diagnosis is 70%. So our given data is 60%, 40%, and 70%. If the patient of Dr. A, Dr. A, who had diseases X, dies, what is the chances diseases diagnosed correctly? So now we have to consider E1. This is X is diagnosed correctly by the Dr. A. E to be this the patient of A who, who has diseases X died. So only that correctly or died. There are two possibilities. Okay. So once here we know this P of E1 and P of E2 by E1, P of E2 and P of E2 by E2. We know this. Simply we are using this Bayes theorem, so we got the solutions. So once we know this, the event. Here the question is what? A patient of Dr. A who had diseases A died. So simply will be mentioned by the event. Event is mentioned. So our question is once we know this the favorable event is what always using the Bayes theorems. Okay. Next, the random variables. Random variable means simply it is defined by a collections of finite or infinite numbers. That's all. A finite of the collections of finite or infinite numbers. It is called what? Random variables. So for example, tossing a coin in two times. What are the possibilities? Head, 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 tail, head. How many possible events? Four, no? So it is for what? Random variable. Here there are two different ways. One is discrete random variable, another one is continuous random variable. Discrete means once the countable infinite or finite value is called our discrete random variable. Uncountable infinite or finite variable is called what? Continuous random variable. Here, the probability density functions or probability mass function is defined by the total probability. This would be 1. This is called probability mass functions or probability density functions. So for example, you see here, the probability density function is given by P of x. Probability density function is given here. The minus infinity to plus infinity x limits. Find the values. PDF probability density function means what the probability should be 1. So it is continuous or discrete. Once it is countable, it is discrete. If uncountable, it is continuous. Simply, for given limits, it is continuous random variable. In this case, we know that the total probability equal to 1. No? So the integral minus infinity to plus infinity probability of x is dx is equal to 1. This is a formula. Means p of x is given k into e power minus x square by 2. Simply we substitute the given probability function and just integrate and equating to 1. So we have to get in k values 1 by root 1. Suppose if given the discrete cases, the similar way we given the discrete cases, suppose probability of x is equal to, you see here, this examples, probability of x equal to x is 0, 1, 2. Probability of x is k by 4, k by 2, k by 4. This is given. In the discrete cases, we use always summation. Total probability, sum of probability is equal to 1. So just we adding this all the probability and equating to 1, and we identify the value of k. Here, we are using this concept. You see here, this is a formula for probability density functions and probability mass functions for the discrete cases. Cumulative means, this is the definitions of cumulative. Probability of x less than or equal to x is will be written as sum of xi less than x probability of xi. எவ்வளோ போட்டுக்கோங்க 10%, 5%. ஒரு வந்து போட்டுக்கோங்க. கார்டு தரணுமா? கார்டு வேணுமா? இல்லை போட்டுக்கோங்க. நம்பர் சொல்லுங்கள். This is the properties of cumulative probability density functions. Okay. Suppose we given the probability density function distributions capital F of x, that means cumulative distribution function. The differentiation of cumulative is we getting PDF, probability density functions. In capital F means here mentioned by cumulative distribution function. Small f means density function. Capital F of minus infinity is always 0. F of infinity is 1. Suppose we are asking the probability of a less than or equal to x less than or equal to b is integral a to b f of x dx is equal to f of b minus f of a. This is after integration we substitute the limits. Next, a discrete and continuous, mean, variance and standard deviations. Mean is also expectation, mu, x bar, e of x. These are what mean. Expectation of x is sum of x into p of x. This is the same thing. If x be this continuous, e of x is equal to integral a to b x into f of x dx. Variance means we know this the variance. Variance of x is equal to expectation of x square minus expectation of x whole square. Standard deviation means just the square root of variance is what? Standard deviations. Now the properties of expectation is expectation of any constants multiply with any variable. Just we take outside the constants. Suppose the variance of any constant is equal to 0, but expectation of any constant is constant. These are the properties of variance and mean. Now see here, for example, in this example, x denotes the number of heads in a single tosses 4 fair coins. Determine x less than 2, 1 less than x less than 3. First we identify the properties, possible property. How many coins is tossed? 4 coins, So the number of sample space is 4 square, so 16. 16 is a possibilities. Now the probability of getting x is we consider 0, 1, 2, 3, 4. These are the possibilities. Number of heads. Heads means 1 is the possibilities. No, number of heads. Number of heads is we consider 0, 1 or 2 or 3 or 4. This is the possibilities. It's correct. now total possibility is 16. No hits means the corresponding probability is 1 by 16. Only one heads means 4 possibilities. That means we have to identify head, 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 head. Next, head, head, tail, head. In this way, we have to identify the possibility. Totally 16 possibilities. So no heads 1 by 16. Only one heads 4 by 16. 2 heads means 6 by 16. 3 heads means 4 by 16. 4 heads means 1 by 16. After this, what is the question's probability of x less than 2? Less than 2 means only consider x be this 0 and now the corresponding probability is 1 by 16 and 4 by 16. Just we take the addition 5 by 16. Next, probability of 1 less than x less than or equal to 3. 1 less than x less than or equal to 3 means we consider up to 2 and 3. The corresponding to probability is 6 by 16 and the probability of 3 is 4 by 16. We take additions 10 by 16. We simplify 5 by 8. In this way only we have to find out all the expectations. Suppose we are asking this mean. This question is what? If we are given the probability distribution directly, our question is only asking mean. We know this, the mean is what? Sum of x into f of x. So x f of x, we know this. Just we will multiply each terms. Minus 1 into 0.3 plus 0 into 0.1, 1 into 0.1, 2 into 0.3, 3 into 0.2. Just we simplify, we will get the answers. Variance means we apply e of x square minus e of x whole square. Similarly, how to find out e of x square here? Minus 1 whole square into 0.3 plus 0 square into 0.1, 1 square into 0.1, 2 square into 0.3 and so on. Okay. Next. If the random variable has the probability density functions f of x is equal to 2 e power minus 2x for x greater than 0. 0 is excellent. Find the probability of lies between what 1 and 3. Just we use the formula for integral a to b f of x dx. Here a is 1, b is 3. So probability of 1 less than or equal to x less than or equal to 3 is 1 to 3. Given the probability is what only x greater than 0, we consider the function is 2 into e power minus 2x. If x is less than or equal to 0, then consider the function is 0. So 2 e power minus 2x into dx. We substitute e power minus 2 minus e power minus 6. We get the answers. Okay, right. So this is for the random variables of discrete and continuous. Also. Now I have some standard distributions. Standard distributions means discrete and continuous. Here, this discrete and distribution is also called binomial, Poisson, geometric. These distributions is what? Discrete distributions. A continuous distribution is exponential, uniform, and gamma, and so on. These are normal distributions. These are what? Continuous distributions. Okay. Binomial distributions means probability of x is equal to x is ncx into p power x into p power n minus x. Here, n is for the parameter, where p be this probability of success, q be this probability of failures. Okay, the mean of binomial distribution is np. Variance of binomial distributions is npq. Standard deviation is root of nq. Similarly, Poisson distributions. Poisson. Probability of x is equal to e power minus lambda, lambda power x by x factor. This is for Poisson distributions. The mean and variance should be lambda. Yeah. Next, the normal solutions. F of x is equal to 1 by sigma into root of 2 pi equal minus 1 by 2 x minus 2 by sigma whole square. Okay. And mean is mean, variance is sigma square, standard deviation is sigma, and mode is mu, mean is mu, and so on. Okay. By using once we want this calculate for the, any probability any problems in solving to probability, we using this different kinds of formulas. Okay. I will be forward for this notes. Just we go through. If you got any doubt, we have to share to me, or we call to me anytime. I'll be referred. Amrit,
Yes, sir. Sir,
uh,
main PDF,
yeah,
sir, and the
yeah.
material.
I will be sent to anyone mail ID. Okay, just we have to chat my chat box. Anyone send to mail ID.
Okay, sir. I
I'll
will
be
send.
forward. All
Okay, sir.
others are you will be forward to all other
Yes,
students.
sir.
Okay.
I will forward it, sir.
Uh,
Okay, sir.
just in your chat box, we will be type your mail ID. Okay. If you have any doubt, we have to chat. Okay. If you have any doubts, any clarifications. Um, anyway, in numerical methods is also in our syllabus. They have a little bits concepts. How to solve the solutions of linear uh, system of equations. That means solutions of simultaneous equations. They have using the solutions of simultaneous equations is there are four different ways. One is a Gauss elimination, Gauss Jordan, and a Gauss Seidel, Gauss Jacobi. This first two method is called the matrices method. This is a easy way to find out solutions of simultaneous equations. I suppose you asked the question is we solve the system of equations by using Gauss elimination. First of all, we have to given the system of equations write down in this matrices form. Already we know this. The system of equation is also will be written as Ax is equal to b. After return, we have to convert it to lower triangular or upper triangular. This is same as the consistency. How to find out the rank? The similar way we have to convert it to upper triangular or lower triangular matrix. Just we are to getting and back we using this backwards solutions. To solve the backwards solutions, automatically will be get the direct answers for x, y, z. That means unknown values. Okay. In Gauss Jordan means we have to try to after writing the matrices form, we try to convert diagonal or unit matrix. Diagonal or unit matrix. After conversions, directly will be got it the solutions. Okay. In a Gauss elimination method, we have to use this backward substitutions. Then only we got the answers. But Gauss Jordan method, directly we have to identify the solutions of x, y, z. It is called what? Gauss Jordan. Next, in Gauss Seidel and Gauss Jacobi is iterative method. If you want this undetermined solutions, that means decimal values, we have to use the iterative method for the system of linear equations. In this Gauss iterative method, means Gauss uh, I- Gauss Jacobi method means always we have to apply the previous iterative values up to until we getting the consecutive iterative values are same. Consecutive iterative values are similar, then only we have to apply the Gauss Jacobi method. We have to apply always previous iterative value. But in Gauss Seidel method, we apply the current value of x, y, z. Current value of x, y, z. Suppose if you apply y and z, before whatever you will be founded the value of x, y, z will be substituted here. Right? Until you getting the consecutive iteratives for set. These are solutions of solving Gauss system of equation, Gauss elimination, Gauss Jordan, Gauss Jacobi, Gauss Seidel. This best method for to find out the solutions of system of equation is Gauss Seidel. This is for best method. Okay. Next, how to find out the initial value problem for the ordinary differential equation. Yeah, the initial value problem is I have using for two different ways. One is a single step method, another one is multi-step method. In a single step method, they have four different ways. One is Taylor series method, Euler's method, Euler's modified method, and Runge-Kutta method. In a Runge-Kutta method, they have four orders there: first order, second order, third order, and fourth order. Moreover, we using this fourth order only for. In a multi-step method, there are two different ways. Millin's predictor corrector method and Adams predictor and corrector method. This is the formula for the Taylor series. Yn plus 1 is equal to yn plus h by 1 factorial yn dash plus h square by 2 factorial yn double dash plus 1. This is for formula for Taylor series method. Euler's means yn plus 1 is equal to yn plus h into f of xn comma yn. This is the formula for Euler's method. Here Euler's modified and Euler's improved Euler's method. There are two different ways there. This is the formula for Euler's modified method. This is the formula for the Runge-Kutta fourth order. Actually, this yn plus 1 is equal to yn plus 1 by 6 k1 plus 2k2 plus k2 2k3 plus k4, where k1 be this h of x1 f of xn comma yn, k2 be this h of f of xn plus h by 2 yn plus k1 by 2, k3 is h of f of xn plus h by 2 yn plus k2 by 2, k4 is h f of xn plus h yn plus k3. This is a multi-steps method that I have using for yn plus 3. This is equal to, they have two different ways. One is a predictive formula, another one is corrector formula. y0 plus 4h by 3 2y1 dash minus y2 dash plus 2y3 dash. Y corrector formula is y2 plus h by 3 y2 dash plus 4 y3 dash plus y4 dash. This is a formula for predictor. In this numerical methods concept, moreover, we are asking only for simple questions or simple functions is given. Otherwise, we are asking the problem only. Okay. Let's go through for these topics for numerical methods. If you have any doubt, any clarifications about our anyone? Any questions? Questions? Any questions? Amrit.
No, sir. Thank you, sir.